Hello everyone. Today we'll be covering Chapter 3, Factors of Polynomials, and Chapter 5, Simultaneous Equations. So let's just get started. So what are polynomials? So polynomials is any equation or function that contains two or more terms. So one-term polynomials are called monomial, two-term polynomials are called binomial, and three-term polynomials are called trinomial. So there are two key topics we will be covering, the factor theorem and the remainder theorem. So what is the factor theorem? The factor theorem states that a polynomial f of x has a factor of x minus c if and only if f of c is 0. So what does this mean is, if you take any linear or linear equation, let's say, so there's a example here. You can see the f of x is x cubed plus 4x squared plus x minus 6. So you need to use the factor theorem to show that this x plus 2 is a factor. So this should be always a linear. To know that, you can use it to find the, using the factor theorem, you can show that this is the factor. So this linear equation, how do you use this in the factor theorem? So as we saw, you need to convert x minus c. If it is in an x minus c form, the function of c should be equal to 0. Here it is in x plus 2. So what you do is, you set the x plus 2 to 0 and find the x value, which is x is equal to minus 2. So this x is equal to minus 2 should be should be substituted in the function. And if this gives the 0, then you can say that x plus 2 is the factor of f of x. So as we know, f of negative 2 cubed plus 4 times negative 2 squared plus x and minus 6 plus, plus x should be negative 2, negative 6. So this gives the 0. And if this gives the 0, x plus 2 is the factor of this function. Got it? Okay. Now let's move on to the remainder theorem. Remainder theorem is just the converse of what factor theorem. So it states that when a polynomial p of x or f of x, you can call this f of x also, is divided by a linear polynomial. It should be a linear polynomial, as we said before. It should be not x squared or something to the power raised to 2. Should be the x should be raised to 1. And this linear polynomial, um, x minus c, if it is in the form of x minus c, then the remainder of this division as in you're dividing the f of x by this x minus c, and you get a quotient, and the remainder will be the p x f of c. So this remainder. So how actually the factor theorem comes from the remainder theorem itself. So if as you know, when you're dividing in your normal division, if this remainder is 0, then you say that this is the factor of this, or this is a factor of this. But if it is some remainder other than that, so if it is not equal to 0, this f of c is not equal to 0, then this is the remainder. This is how you find the remainder of any polynomial, which when it's divided by a linear polynomial, you get the remainder f of c. So now let's see an example here. So the cubic polynomial f of x is defined by f of x equals to 4x cubed minus 7x minus 3. So to find the remainder when it is divided by x minus 2. So the c here is 2. So the c here is 2. As we saw, it should be, you initiated the x minus 2, whichever the divisor you're solving, to 0. and then you find the x value you're going to use in the function to find the remainder. So you will use this function, use this x value in the function, in the function to find remainder. Okay, so you set f to 2, the x inside it will be 2, and then you get 4 times 2 cubed minus 7 times 2 minus 3, and then you get the answer as 832 minus 3 is 29. 29 minus 14 would be 20, minus 14 would be 15. Okay, so the remainder is 15. So now let's go to the second part of the question. Show that 2x plus 1 is the factor. So use the factor theorem again to show it. I hope you know how to do it. From the previous slide, we saw how to do it with a different function. Here, you need to factorize this function completely. How you do? So there are two main methods. One is by long division or synthetic division. Synthetic division. For IGCSE syllabus, the synthetic division is removed as of such for the latest syllabus. Only you use the long division method to find the factorized form. So how you do that? You need to do the long division as such. So this, and you add a 0x. So you need to know that it's the 0x in the term because 0x squared. Sorry, it should be 0x squared. 0x squared. So as such, they didn't give you the x squared term, but it's implied that it is a 0. And then you just copy the same, and then you divide it by 2x plus 1. From first, you should have shown that it's a factor, 2x plus 1. So how you do it? So you can multiply it by 2 first, 2x squared, because x squared times x will be x cubed, and 2 times 2 would be 4. You can cancel this out, and this would be 2x squared. So this is a negative 2x squared, negative 7x, and then you again do the same thing. Again, if it's negative 2, it should be negative x. So negative 2x squared, then minus x, and you get the answer here. It would be negative 6x minus 3. So you again write it as negative 3, which is negative 6x minus 3, which is 0. So the other term is, so the other term for the quadratic term is 2x squared plus x and minus 3. So now you can do the same similar way. You can factorize this to form the other two linear factors. Okay, so the goal when you're factorizing a cubic equation, the goal is to make a linear polynomial and a quadratic polynomial. If you get these two, then you can easily you can factorize it to the simplest form, which is having only linear polynomials in the factorized form. So solving cubic equations. So this is similar as we saw in the previous one. So you need to figure out some number, some linear polynomial, x minus c, to which is a factor of this. So first you need to figure a linear polynomial which is a factor. That you can do it by the factor theorem. So the factor theorem, you can use it again to find the linear polynomial. Then you can do the long division. So the first step 1 is to find a polynomial that is a factor of the fx. So if this is the fx, so the function's factor. Step 2 is to do the long division, and then step 3 is to factorize it completely. Factorize the quadratic completely. So when you use these three steps, it's you're clear with the concept, and you're telling the examiner that you know how to solve any cubic equation using the factorized form. All right. Okay. Now we'll move on to chapter 5, simultaneous equations. So if you have any doubts, you can post it on the WhatsApp group. So chapter 5 for simultaneous equations. There are two methods to solve any simultaneous equations. So simultaneous equations is basically any equation that uh, that occurs in a similar way, so you can solve both of them simultaneously. So that's what means by simultaneous equations. So there are two methods, substitution method and elimination method. Let's look at the substitution first. So here you have 3x plus y equals to 7 and 3x plus 2y equals to 8. First thing is to assign both some subject. So let's say this is the first equation and this is the second equation. So now what you do, you can write the first equation as from 1. So from equation number 1, you get y equals to 7 minus 3x. So you need to make something the subject, either the x or the y for any of the equation. Then you substitute this into the other equation. So if let's say this is the third equation we got from the first. So now you need to substitute 3 into 2. So the key thing here is you should not substitute whatever you got in the same equation. It should be the second equation or any other equation which is coming with it. So now when you substitute this into this, so 3x will be 3x plus 2 times 7 minus 3x equals to 8. So 3x plus 14 minus 6x equals to 8. Now you can see that it's negative 3x equals to 8 minus 14 is negative 6 and x is equal to 2. So this is the substitution method. But there's another simpler way, which is the elimination method, which we will use, we'll see here. So we are using the same equations here also. We'll use the same examples, 3x plus 2y equals to 8. This is equation 1, this is equation 2. So eliminate means you need to eliminate either the x value or the y value. So whichever is easier to eliminate when you see it, that you can use that method. You can so here let's tell that we want to eliminate this 3x because 3x is common in both of the equations. We can eliminate easily. So what you need to do, you need to subtract the second equation from the first, or you can do the other way around, from the first equation and then minus the second. I did this because 8 minus 7 gives a positive number and it will be easier to calculate with positive integers. So when you do this, you cancel these two out. So 3x and 3x will be 3x minus 3x is 0 and 2y minus y will be y, which is equal to 1. And then after you find the value of one of the variables, you can substitute into any of the equation, either the 1 or equation number 2 to find the x value. So let's substitute, let's say in 1. So substitute y into 1. So y into 1. What you get? 3x x plus 1 equals to 7, x equals to 6 divided by 3, which is 2. So this is the elimination method. So there are some questions in the additional math syllabus which involve non-linear. So there will be some non-linear functions, polynomials also. So you can have quadratics, cubics, anything other than just the linear functions, where you will get one of them as, like, let's say a linear function and another one as a non-linear function. So let's say 2y equals to 1. So when you do this, the only method you can use is to substitute, because there are no terms which are common. Only you can say that y equals to 8 minus 3x, then you can substitute 8 minus 3x as y here and then solve it as a quadratic equation. So mostly you can use substitution method if questions comes like this, because it's easier and it's more clearer than the elimination method, because sometimes students get confused in the elimination method whether to subtract this from that or that from this and then find the uh, x values or the y values. So substitution method is a better way to go when you're dealing with nonlinear functions. So here's a small practice. So with the nonlinear functions, as we saw before, with a nonlinear function, let's practice. So I'll just give you some time here. Okay, now let's move on to solving this. So the first equation is 3x plus y equals to 11, which is equation number 1. X square minus 2y equals to 18, which is equation number 2. So as I said, if when dealing with nonlinear functions, always go with substitution. Substitution is the best and risk-free way. It's a risk-free way to go when you're dealing with nonlinear functions. So let's say from 1, we get y equals to 11 minus 3x. So this is the third equation we got from 1. Now we substitute 3 into 2. Remember to substitute only the third equation with another equation and not the same one. So it should not be the same one, because when you do it in the same one, you get a 0 in both the sides and then you won't be able to solve it. So whenever there are some simultaneous equations which you need to form, in some questions they ask you to form those simultaneous equations before you solve it. You need to look at the number of terms you have. So number of variables, sorry. So if you have 3 variables, here there are only 2. If you have three variables, the rule is to form 3 equations. If there are 4 variables, then the rule is to form 4 equations. So this is how you can remember the number of variables in an equation equals to the number of equations you need to form. So here when you substitute 3 into 2, you get x squared minus 2 times 11 minus 3x, which is equal to 18. And then you can write this x squared minus 22 plus 6x equals to 18. And then solve this quadratic as such. So you get x squared minus plus 6x minus 8, 9, 10, 40. So now you can solve this to find the x value, and then substitute this x value into any of the equations, either 1, 2, or 3, to find the y value. Got it? Okay, I think we have come to the end of today's revision. Thank you for coming, and we'll see you tomorrow.